Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we've got Matt Pocock. Matt, how you doing?
Good, thanks, pal. How are you doing?
I'm doing great. I'm so excited to have you on the show. I feel like you have sort of rocketed up in visibility as a great educator in the TypeScript space. You've got this great new course coming out with like wizard illustrations. It's really something special. But you're like brand new to this whole teacher thing, or I guess not to the teacher thing, to the JavaScript thing. So let's maybe have a bit of a background on you for folks who are just becoming familiar with who you are.
Sounds good. So my weird background is that I was a singing and voice teacher for 6 years before I became a dev. Like that's kind of where I don't know, it's where my heart is, but it's definitely where like the bulk of my experience is.
Sure.
I've been a teacher for a lot longer than I've been a dev, and I was a dev for, I think I started building applications like for my students, like building these sort of weird voice apps that would like tell you the quality of your voice and like all this kind of crazy stuff using like web audio APIs. Like that was my first JavaScript app, was like diving deep into the web audio API and doing Fourier transforms and stuff and blah, blah, blah. And I went from that and I realized I could probably get a job as a junior dev. So I got a job as a junior dev. Then my next job, I was a mid-level dev. My next job, I was a senior dev. My next job, I was a lead dev. And now I'm here. So I'm working at Vercel. So it's kind of mad, really. It's felt a bit like a rocket ride. And I think a lot of that is just being able to blag my way into situations that I have no business being in. And I think the accent helps as well.
I think we have proven that you sound 20 IQ points smarter whenever you have a British accent.
Yeah. I think so. I think you sound more charismatic as an American, though. I think that's my take.
Yeah, no, I think the thing that I've noticed is like there really is a musician to engineering pipeline. Because that I think it's a similar problem solving space, right? Like you're looking at patterns, you're looking at ways to combine old patterns in new and novel constructions, and that's what makes things interesting and that's what makes things exciting. And so what I found was like, I've made this joke before, but when I was a musician, when the band broke up, I learned that really the only thing about being a musician that I wasn't good at was making music. All of the other parts, the booking and the like, all these things that were business skills, right? Like how to go on tour, and then also the construction parts of music, like understanding patterns and all those other things, that all felt good to me. So when I moved into dev, I was like, oh man, like 95% of these skills crossed over. It's really interesting to see how that works. But so, yeah. So
in many ways, like dev is a kind of more limited language often than music itself. Like music feels a lot more broad in terms of like the genre and the stuff you have available to you. It feels like you could go massively into depth in terms of harmony and scales and stuff. And JavaScript, like its API surface is tiny in comparison to music itself.
Yeah. And we're seeing like a couple really good comments here. Like music is the original programming language. That's true. Because if you think about it, when you write sheet music, you are providing a set of instructions to to a machine. The machine was hand operated like a piano or a violin or whatever, but it's machine instructions. So that's fascinating. Math is the OG program language. Yeah, you're probably right. But like it's really, this stuff is so fascinating to me because it really is it all just comes down to like patterns, right? How do you communicate to somebody else what you wanted, what you intended? And so
totally. For me, the other thing too was like it's like the problem solving element of teaching was something I just got addicted to. Like especially with like singing teaching and voice teaching, someone comes to you with like a specific problem, like I can't hit this note, and it's like a mechanical thing. Often it's an emotional thing too. Like you have a sense of the person feels like they can't get there, and so their body tenses up and all this sort of thing. And you get all this tension, and so it's correcting that mechanically is so interesting, and there's so much in-depth knowledge out there. And so coming to dev, that felt like, oh, okay, this is just, we have this very complex system that we're building. And it was actually felt much easier than voice teaching, weirdly, because everything, you can't like componentize the voice, like,
Sure.
so yeah.
Yeah, that is actually something that's interesting. Like you can abstract certain things, right? Like you can go out and get a drum machine or something and play loops, but like it's not the same as when you componentize code. Like there's some really interesting stuff you can do with abstractions in code and all of that. But that maybe is a slightly clumsy segue into what we're talking about today, which is TypeScript, which is a layer of abstraction on top of JavaScript that adds typing, right? And so this has been the sort of thing that I think for a lot of JavaScript devs, myself included, TypeScript is a source of a lot of anxiety because it's just JavaScript, except it's definitely not. And you get mystery errors, and there's sort of a programming language itself within TypeScript. And so I get certain things. Like if I'm just going to write a type and say, okay, I've got like a book, and the book needs an author and a title and a publication date, and I can just say, okay, well the title's a string, the author is going to be a string, or maybe an author object if we've got more details. That all makes sense to me. But then you start getting into stuff that is absolute, just so out of my comfort zone. Like, why does this say like angle brackets T, and then there's like, this, all these other things that are happening. I'm like, okay, but what is that? Why does that exist? And so that's what we kind of want to dig into today. We've talked about the early layers of TypeScript on the show before. We've had several great episodes. I'll make sure that those show up into the show notes for folks. Where actually, you know what I'm going to do? I'm just going to link to the whole TypeScript collection on Learn with Jason, because we've got all sorts of good stuff in here. Actually, more episodes than I thought. Yeah, 6 episodes that dig into TypeScript on Learn with Jason.
Nice.
But most of those have stayed away from some of these more advanced topics because we were trying to build the foundational knowledge. So we're going to skip over all that today. So anybody who's watching this, if you've never used TypeScript before, you might want to catch the video on demand, because you're going to want to watch some of the foundational stuff of like, what exactly are types, and how do you set up a TypeScript repo with the TS CLI and stuff like that. So, Matt, why would someone need this like really advanced TypeScript?
Yeah, so it's interesting because TypeScript is like, it's just JavaScript, it's JavaScript, except I kind of like to think of it as it's kind of like you're speaking English, except it's almost like you've got your English teacher watching over you doing like squiggly red lines on your work as you're writing it, And a lot of people react really badly to that. They feel like, okay, this is just awful and terrifying. And they get good enough at TypeScript that they can just make the red lines go away. And they feel like, that's great. I've mastered TypeScript. I now know what my teacher is saying to me. I understand it. And that's really, really good for if you're writing applications and if you're consuming types kind of that are from other libraries. So if you think you're building like a Next.js app, for example, you might want like some type checking on get static props or like all that sort of thing. And those type definitions that you pull in from a library, they have been crafted by someone. And a lot of that type code is really complicated. And it's complicated in a way that it's pulling out different bits of inference, and it's like pulling things together. And TypeScript is an incredibly powerful language when you get into the really deep stuff. And what it allows you to do is it allows you to build incredibly flexible APIs that then application developers can consume. So what it means is you get to be at the top, trickling down all this beautiful inference and knowledge and power down to those below you. And it means that you can become an enabler for your team. You can become the TypeScript wizard on your team that can just build these very simple APIs that are easy to use and consume, but that enable incredibly powerful type checking for free, basically.
Yeah. And so if I kind of grossly oversimplify what you just said, when we're talking about libraries are dealing with a lot of unknown inputs. And so TypeScript gives you that really advanced capability to do the inference and all the things that you need so that you still get typing as you're using arbitrary userland code. So that's a really good use case for advanced TypeScript. If you're writing a library yourself and you know what the inputs are and you're not taking a bunch of arbitrary userland code, you may not ever need this. Is that a fair assumption?
Yeah, I think if you're consuming like stuff from, I mean, I think the point is really, or the dividing line is, if you're writing an abstraction, and virtually any abstraction, then you're probably going to need some kind of even intermediate to advanced TypeScript to make that abstraction feel powerful. Because in JavaScript, you can basically pull anything into a function, return anything out of a function, do crazy stuff like all through, and like if you're not using TypeScript to its fullest extent, you're probably going to end up with the user themselves having to annotate the code that they're writing with like, this is this shape and this is this shape. Whereas if you can get it to a point where it's being inferred throughout that in any abstraction that you write, then you're probably going to have a good time using advanced TypeScript. Gotcha. Because really, I mean, if you're building in a team, abstractions can be force multipliers for that team. And it doesn't matter whether you're in a library or you're in an application, then if you're building your abstractions or if you're in charge of them, then you can really enable a lot of power to people.
Okay, so then a revision then, if I can kind of walk this back a little bit, is that where these generics and other advanced TypeScript concepts really start to shine is when you are building code for writing code, right? Like if you're exactly. building an application and you're going to ship that and that's what runs in the browser, you probably can figure out enough about how your code works to not need any of these really advanced things. And personally, I'm a big fan of like, if you can refactor something to be just a standard type, you probably should, right? Like don't get clever if you don't need to get clever. But as you start writing code that's a layer of abstraction to empower other devs to build more things, you've found a common pattern and people are going to wrap all their code with this thing that adds something, then suddenly you have this deeper need to like accommodate for people who are going to do arbitrary stuff, and you want to support that without making them do a bunch of extra lifting.
Exactly. And that's kind of every dev's dream, really, is to like write code that empowers other devs. That's a lot of why people get excited about open source work, about why they feel rewarded when people use their libraries, is because they're enabling other people to move faster. And that's what this allows you to do.
Absolutely. Okay. So I've said the word generic a couple times, and I'm gonna do a little confession here. I don't know what that is. So in the highest like lowest level of fidelity, what is a generic in TypeScript?
Yep. Imagine you have a function. A function takes in something and it returns something.
Right.
A generic, a standard type is just a static variable, like you have interface book, for instance, it has its author ID, it has blah, 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 blah. But what if you wanted to create different types of books that all had different shapes within them? Okay. Then in JavaScript, you would create a function where you would say, okay, I've got my book, and then inside my book, I'm going to have something else. So imagine if you have like an interface for when you return some data, for instance, from Axios or Fetch. You would say, okay, I've got my data, but I don't quite know what that is. So I'm going to make a function which takes in the type that I want to attach to that data. And that is a generic. That's a generic type.
Okay. I
can't wait to explain this with code. My God,
I think that, I'm actually wondering if we should do it. Okay. So, but first we've got one, I don't even know if this is a spicy question, but it's a good question here. So Big Hairy Dude, nod for the wonderful username, asks, are generics a workaround for the fact that TypeScript has locked you into types?
No, I don't think so. I think you might mean like has locked you into using types, has forced you to make sure everything is correct. At least that's my interpretation of the question.
Yeah, because so like my gut feel on that is no, because the workaround is to just mark everything as any. Like if I have a library and I'm like, I don't want to figure out how to type this thing because you're literally passing arbitrary code, then I would just make an argument called code, type it as any, and you send me whatever you want. Right? So that feels like the workaround. So generics are almost the solution to needing that workaround.
Yeah, exactly. They let you hack into TypeScript inference and let you kind of build these APIs that allow TypeScript to understand the flow of your code a lot better. Because that's really what TypeScript wants to do most of all, is it just wants to understand what your JavaScript is doing. And it's really good at that in a bunch of different ways, but it has limits, and these allow you to extend those limits outwards.
Gotcha. Okay. All right. I'm with you. I'm feeling it. Okay. So, knowing that the rest of my questions are absolutely going to be easier to explain in code, why don't we just hop into code and make that happen? So I'm going to take us over to, let me get the right things on screen here so that I'm not putting us into the infinite loop. And then I'm going to take us over into pair programming view. And so first, this episode, like every episode, is being live captioned. We have Amanda here with us today from White Coat Captioning, taking down all of these words. Thank you very much. If you want to watch that, that is on the homepage of the site at learnwithjason.dev. We are also talking to Matt Pocock today, who is on Twitter at Matt Pocock UK. That's not right. What did I miss? Oh, I added too many K's in your name.
Pocock. That's good. I think we could refactor to that probably.
So let me drop this one in here. Everybody go give Matt a follow. And we are talking about TypeScript, which is something that you've been working on a lot. You've got this this total TypeScript site that is absolutely gorgeous, by the way. Look at these illustrations. Really just some good stuff going on in here with like it really.
I did not do this. My favorite bit is this this error message on fire. I said to the illustrator, I want the error message to look like it's coming from the depths of hell. And she did an amazing job.
It's so good. It's so good. No, this is wonderful. So I love it. This is this is really fun. Everybody go check this out. Make sure you get on the there's an email list on here, right? And that has a bunch of free resources on it. So make sure you get there. And with that, I have absolutely no idea what to do next. You had me, let's see, let me clear this out. You had me download this repo. And Correct. So I've got that. And that's over here.
So yeah, this is on, maybe we want to link this as well. This is the total TypeScript / what is it? Generics, yes. TypeScript generics tutorial.
All right, so let me find that. It was here. We're going to go to github.com, total TypeScript. And then I need this name here.
Yep, you got it.
Here it is. Okay, let me throw this to everybody. There you go. Got a lively discussion about generics happening. Thank you all for getting in there. I'm looking to see if there are questions. It doesn't look like there are, so we'll just carry on ahead. So, all right, we've got this repo. And this repo is part of the total TypeScript thing, but we are getting into generics today, which is the advanced TypeScript that we want to learn. And I've cloned it. I have it here. So what should I do first? Like, do you want to do a little tour of the repo?
Yeah, sounds good. If you go, the repo is pretty simple, really.
Okay.
If you go into the source directory, what you'll see is a bunch of different problems and solutions. And all you've got to do to complete this repository, to complete these exercises, is go through them one by one, look at the problem first, and then see if you can solve the problem that's in there. Usually that problem is going to be there's a type error in there, or there's something wrong with it. A lot of them are not kind of explained perfectly. Like I haven't gone through and added comments through all of these because this is semi-work in progress still. But what you should do is just see if you can solve the problem and understand it. And then when you feel like you've finished, go have a look at the solution or solutions, if there are multiple, because the solutions are usually telling you different ways that you could have solved the problem. And what you can do as well is when you finish this, you can go in chat as well. We can do this together at the same time. And you can also ping me on my Discord as well, because there's a bunch of people in my Discord going through this, and I should drop a link into the chat as
Yeah,
well.
is that in here somewhere?
Unfortunately, it's not. No, it's not linked up yet. It's relatively new, my Discord. I will drop an invite now in the chat.
Okay.
But that's the fundamental stuff to do with the repo. What we should probably do is do an npm install. That's the next step.
npm install. Okay, so here we go. And here's the Discord. I'll go ahead and accept that invite now. Actually, I can't because I don't have Discord open, so I'll do that later. But yeah, so oh, that installed faster than I expected. I thought we were gonna have to kill some time. I was ready to vamp.
No dependencies on TypeScript. Yeah, no, we're good. No, there's not much in here. So now all you've got to do is run npm run exercise 01. Very nice. So what this is going to do then is it's going to go into, we finished the exercise. That's unexpected. But if you go into exercise 01, what you'll see is that there's a challenge in there. And there's a comment at the top.
Okay, so all right, let's take a look here. How do we refactor these to reduce the duplication in the data declaration? So we've got user data that has data. We have post data that has data, comment. All right.
And then this stuff at the bottom is basically a bunch of tests. It's testing that the types above it are what they say they are. So if you comment out line 24, for instance, on that comment, and just remove that, then we're going to get a type error down the bottom.
Oh, and it's running as we go. Oh, perfect. All right,
let me go to error 2.
Let me pull this over here, and then I'm going to close this up. And then we get an error down here. Nice. Okay, great.
So here our challenge is we've got these 3 objects, and they all specify a data attribute. It's kind of what I was describing before, actually. And so there's an opportunity to dry up this code. We can take these like post data, comment data, and the other data, I can't remember what it's called, user data. And we can, there is a way using TypeScript that we can dry them up. So with your extensive knowledge of generics, Jason, why don't you take us through exactly how we do that?
Okay, so here's my guess is if I wanted to pseudocode this, I need an interface for like a data wrapper, and that will take one field of data, and then that needs to accept options. It'll take a user, it'll take a post, or it'll take a comment, right? And so that would be my gut, and then you're making it sound like this should be generic. So the data should take a generic. Okay, so if I do, let me see what I can figure out, because again, I haven't actually written one of these before. So I'm going to say interface data, and then generic is the T, is that right?
Correct, yep.
So I just put a T in, and then in here, my new user data would be like export interface user data, or user data extends implements. Nope, what is it? Something data.
Yep.
Right. Well, but then it's still going to be okay. I now need to know more about how this works to start, because if I was going to do it this way, I'm already like, all I'm doing is saying, oh, this should be data, and that wouldn't work. So I would instead want it to be interface user, which would be these. Okay. And now I don't know what I'm doing. I need to get this into here.
Yeah, what I'm seeing is like you're approaching it from like an object-oriented thing, going like it needs to extend from this, when I think you should be thinking of it more of a functional way. So why don't I drive, which is you are super close with this. You can see my cursor, right? Yeah.
Yep.
So, by the way, we're using live share to sort of pull me into this as well. I'm not sort of magically hacking into JSON stuff. So this data thing here, we've got, let's actually call this data wrapper because that's a perfect name.
Okay.
And I'm actually going to, what we kind of want here is we want a function, which is we have like data wrapper.
You hackers, you dirty hackers.
Mm-hmm. We've got our data wrapper, and we take in our kind of thing, which I'll just call any, and we return data, which is the thing. That's kind of the mental model we need to have here, which is we now need to create this on the type level, because this creates actual runtime objects, but we actually need to put this into the type world. So our data wrapper here needs to somehow take an argument. That's the thing. And the way that argument works is with this syntax.
Okay. All right. So we've just touched on two things that have always confused me. First is the inclusion of these angle brackets, and the second is the letter T. So T, we've decided, is generic. It's a placeholder for whatever type comes in, right? And angle brackets are the equivalent of a function call in a type. Is that correct?
Exactly right. So they're the equivalent. If we could write them with parentheses, we would. We would say like data wrapper T, like this.
Okay.
This is the syntax that TypeScript has chosen.
Got it.
We can call this anything. We can say T data. We can say T JSON, T whatever. We can even just call it thing. We don't need to use the T. T is just a convention. We can add as many as we want. We can go T1, T2, T3. It's just like function arguments.
Got it. Okay. Well, that's, I would say, the first major light bulb moment of the day is demystifying what the heck these are in TypeScript.
Yep.
And to all of you who already know, congratulations. To everybody who just learned along with me, you're one of today's lucky 10,000.
Love it.
And if you don't know that one,
let's call it T data. I do not know that one.
So this is it's a comic from XKCD about learning things. It's very good. There we go.
I can't just read it live on the stream. That's not
no. It'll be in the show notes.
Okay, cool. So yeah, we've now got our function that takes in a T data and returns a wrapper with data T data here. So we can delete this data wrapper because it's kind of doing the same thing but on the type world. And now we've got an issue, which is our user. We've got our user data down there, and we need to somehow call this function to return a new type.
Right.
So the way that we do that is we would say, let's say we have type whatever. And I find myself doing this a lot in TypeScript, by the way, just creating these sort of dummy variables. And I'll show you why in a second. We can say now data wrapper, and we can call it with actually whatever we want. We can call it with, let's just call it with a string, good old string like this. And now if you, Jason, if you hover over this whatever thing here, you'll see it's typed as data wrapper string. Now let's actually create a variable called const whatever, and we're going to give it a type of whatever. Now inside here, if you hover over that error, what's that telling you there?
Property data is missing, but required. Okay, so then if I come in here and I add data, and then I want to do one of these, now it's mad at me because it wants a string. Okay, so now we've got some useful stuff happening.
Yep.
So
definitely. So now,
so I think I can take over from here. I think I just clicked for me. Okay, so what I want is my type of user data to be a data wrapper of user, and then I want this here, because now what I get is if I do a user data, and then I have my data, it auto completes with my stuff.
There you go.
But it wants it to be a string, doesn't it? Yeah. Okay, so did we do it? Is that how you would have done it?
Well, let's check the solutions.
Okay, great. Let me comment this out so that it stops yelling at me, and then we'll open this up. Let's look at a solution. Blow this out a bit. Okay, so we've got the data container. That's what we did. We've got the user data, post data, comment data. Oh, I see. So you abstracted it even further. So you didn't,
Yeah,
or sorry,
I didn't
you
declare
de-abstracted it.
Yeah, I didn't declare the other interface. I just went right in and put the object primitive in there.
Got it. Okay, I didn't know you could do that. So that's really handy. Okay, and then you've got a second solution here. Is that an alternative approach?
That's right, alternative approach.
Okay. So
and that one, I think it's declared data container with a type instead of an interface.
Oh, with a type instead of an interface. And so in this instance, does it matter? What's the difference between a type and an interface?
Nope. Types can represent anything, whereas interfaces can only represent objects and functions in some cases. So there's that's the thing I get asked most of all is should you use a type or an interface? And the answer is you can use whatever you like, basically, as long as you're consistent. It doesn't really matter.
Okay. Cool. Okay.
But there we go.
We did it, y'all.
Finished with number one.
We did a TypeScript. So yeah, this is really, really good. Oh my goodness, my middle name is Danger. Read my book Untethered. I forgot that book existed. Yeah, so that's a blast from the past. I have not done that. Let's see. In 2014, I lived out of a suitcase for a couple years, and I wrote a book about some of the stuff that I did, and how I made that work to be out there. That's what that book is. It's self-published on Amazon. I think a lot of it might be outdated, and it's definitely going to be a surprise what this stream is about if you came looking for untethered contents.
I should say my wife is writing a book as well, actually. She's writing a book on plant identification.
Oh, that's going to be of a lot of interest to my partner. All right, let's do another one. So should we just do these in order, or are there some that you want to highlight here? Because I don't think we'll have time for all of them today.
Number 2 is a banger, so let's do number 2.
Number 2 is a bang. All right. So this one doesn't have a comment on it, so let's just look at what's going on. So this one, let me do 2, and it's mad. It says type false does not satisfy the constraint true. Okay, that makes sense. And let's go and look. So return what I pass in, unknown, it returns it. Interesting.
Yeah,
why does that
tricky.
happen?
Yeah, you think that because really what we want is if you hover over on line 7, if you hover over 1 there, you would expect this to be of type 1 because that's what you've put in there, right? You've put in the literal number 1 and you would expect it to just be returned there. But actually it's typed as unknown.
Mm-hmm.
And the same is true for Matt down below.
Right. Oh, and I see. And down here, we're saying type of 1, type of Matt, and we're not getting that. And so that's where the false is coming from. Okay, so now I understand how these tests work. So I can then up here, we need to figure out how to do. So let's do.
Oh, Jason, don't look at chat because someone's actually already got it right in chat.
Oh, all right, chat. Just let me shield my eyes. All right, so I'm gonna do an interface. And I want it to be, I mean, is it just wouldn't that? No, that's not right. How do you return something from TypeScript? Because what I'm thinking is if we did it as a function, right, it would be, you get a type, and we literally just want to return type.
Yeah.
right? So
one way that you can express that is with a type itself. So you can say type fn. In fact, yeah, you go from there. I'll let you drive.
okay, so I do a type of fn, and then I need to pass it in a t type generic, and then I need it to return. And what I don't know is what's the syntax. Like, you can't just do one of these, right? So what's the syntax here? Is it, no, that's not right either.
I'll give you a clue, which is you're entirely, well, you're on the right track conceptually, but syntactically you're in the wrong place.
Yes. Okay, so if my type is like this, and then it needs to return something, the thing that it returns is one of these, right? But I still don't know. Like, I know I can't just do that. So now I need, this is where my syntax falls apart.
Yeah, this is like so there's a few ways that you can express this, but the way that chat is pointing to is it actually needs to be sort of inside this function declaration here. So we're actually going to inline the generic here.
Okay, so
and
I need to do something like this and then this. No, that didn't
you're
like that.
You're so close. I'm going to just leave this right now, just so that chat tortures themselves for a little second. But you're so close.
That works. What are you doing?
It's really close. Let me show you. So you were dead close with this.
Uh-huh.
But syntactically, all you've got to do is just move this to the other side of the equals. So this now declares it as a generic function instead of a generic type.
Got it.
So what's going on here is that actually, and you were thinking like, how do I return this? Well, in TypeScript, you can declare function return types using this colon here. So if I wanted to say this always returns a string, then I would do this. But actually, let's say we go t item here. T item here too. And here we're actually going to return t item.
Right. So that's a lot of repetition here. Does that dry out at all? Like, because I guess the thing that I notice here is that we've got, like, okay, so we're passing an argument to our type. We're passing an argument of the type to our function, and we're returning our function. So there's not a way for this to like infer where if we were to drop this entirely, it would still work. Clearly not.
Yeah, because it looks, if you do that, it looks for a type in the above scope with t item, like of the name of t item.
Okay, I got you.
So this is kind of like a type variable declaration here, and it's declaring this is available for the rest of the thing. We have to add it here because we have to then assign that to an argument. Right. So that's the reason that's there. We can actually drop this. Really cool thing about TypeScript is that it knows that if you hover over this T just here, you'll see that it's actually typed as T item. So it knows that this is the thing that we're inferring from. So this is the thing that we pass in.
So it can do inference, but you have to make sure that it's got the right places to look. So this is the type declaration, and this is saying where the function uses that type declaration. But if we're just returning it directly, then TypeScript is smart enough to know. Got it. I understand.
Exactly. Yeah. So that's the type declaration, and then that is the type assignation.
And so now if I save this, our test should pass.
Yeah.
It did. Okay, great. And so you've got a couple options in here. So this is like
this
the hard
option. Well, this option, you'll notice that there's no T happening here. This is using a technique called function overloads. And function overloads allow you to actually make the tests pass here. Because what we're saying is on line 3, we've got return what I pass in. If we pass in Matt, return Matt. Up here, if we're saying if we pass in 1, return 1. And then down here, we actually implement the function and we say return what I pass in, which is unknown, and we return the T. And so this does make our test pass.
So this one feels a little bit like when you write a function like is odd, and then you start doing like if number, exactly. Like one of these.
That's such a great way of putting it. Yeah, that meme from I can't remember who posted it.
Right, and then you just find yourself like writing all of these, like, oh, better do another one. Oh, better do another one.
The thing I remember about that, it was such bait for the mansplainers, wasn't it? It was like, did you realize you can use the modulo? It's so good.
Oh my god, that was what was that, Cat Maddox? It was such a good, good post. Let's see if we can. I'm not going to be able to find that actual post, but I am going to find her Twitter because it's amazing. It is full of good information.
Mm-hmm.
Kane now. Okay. Yeah, Kane is freaking hilarious. So all right. So, and then what we've got here is the generic. All right, so I'm going to undo my work in here so that we don't get yeah, there we go. All right. So here's our generic. Great. And that's what we ended up doing. So
yeah, there's one thing to note in here before we continue too, which is that TypeScript gives you really good kind of like Trash is raiding.
Hello, hey, Trash. What's up, Trash? Thank you for the raid.
Trash Welcome, is everyone. He considers himself an acolyte wizard. He's been like going through the type challenges and stuff. He's like a Hogwarts first year, you know what I mean? Just struggling with Lumos and Alohomora and stuff.
Gotcha.
But no, he's actually like, he's passed his AWLs. He's absolutely smashing it. He would absolutely roll through this stuff.
Great.
Okay, so the thing to look at here is that if you hover over, sorry, let me get back to the file on my end. We're in the solution 2, aren't we?
Yeah, do you want me to move back?
No, we're good.
Okay.
If you hover over here, return what I pass in, you'll notice that you see the generic actually get locked in there, which is super duper useful. And if we, let's create another one of this, like const obj equals return what I pass in, and then we can pass in anything, right? So name Matt, age 32, 31 actually. I don't know why GitHub Copilot thought I was 32 there. And then if you hover over return what I pass in, then you actually see all of that stuff as well. So TypeScript is really good at giving you these annotations to tell you what generic has been locked in at what time.
Sorry, the chat is just giving each other crap and it's making me laugh. No, this is the stuff that I think is really, really useful here because this is the piece that's magical, right? So like later when we go to use this, it auto completes for me based on what we're using, right? And so that's the part where like early on when people were telling me about why I should care about TypeScript, and they would talk about, you want like compile errors early and you want to have that type safety. I was like, I don't care. Like, I'll fix that error. Like when the bug happens, I'll fix it. And like, I understand academically, eat your vegetables, write your tests, declare your types, all those things. But also I'm under deadlines and I don't want to do it, right? But then somebody showed me autocomplete and I was like, okay, now I care about TypeScript. Like the idea that if I write these types, I don't have to go look at the code declaration to use it. Absolute game changer. And I think that's the part where I started including, I think first I did the JS doc syntax of like defining all my params so that I'd get type completion. And then I saw like, well, that's not going to be as flexible as you need. So maybe take one step further. So I started writing actual types. And now, if I'm writing something I'm going to share with somebody else, I do it in TypeScript. Not because I care about type safety, but because I care about this autocomplete. I want people to be able to use it without having to think about it. And so that to me was the real killer feature.
It's a way of like passing on the DX baton to your friends. You just get to say, hey, I built this cool thing. You don't really need to look at the docs to know how to use it. Like you can just figure it out. And like, anything you get from it is going to make the rest of your code base better, easier to use, safer too.
Yeah. And and there are like, I've felt all the benefits of like you write your types and then you change something and then you get a type error and you go, oh, I forgot to update that piece of code.
Yeah.
Like, I'm not saying that you shouldn't care about that stuff. You absolutely should. But like where it emotionally struck home for me was auto completion. I was like, oh, this is why people care. Like, this is the magic.
Yeah. It's the feeling of, oh, my teacher actually does want me to do well. You know, like sure, they were being hard on me at the start, but actually they do really know what they're doing. And thank you.
Yes, absolutely. Okay. All right. So what should we do next? Which one should we tackle next?
Let's have a look. So yeah, let's go on to number 3, because number 3 is a good one to introduce some more generic stuff. Let's expand on what we've got
This one is absolutely riddled with errors. Okay, so let's take a look. It's expecting that our string set will be a set of strings, number a set of numbers, unknown set of unknowns, and we are seeing, let's see, we create a set, and that's supposed to be a set of numbers. This says we want to pass in a number. So here, I want this to take a set of numbers, so it should return. Okay, I think I have an idea.
Ooh.
So we are passing in our generic here. So we'll say type, right? And then what we want is to return, and I am making a guess. Did I do it on the first try? Did I just learn TypeScript? What up, chat?
No. Trash, this is how you do it. Trash, by the way. That's how you do it.
That's okay. All right. Well, I'm just gonna take this little clip. I'm gonna put it up on my wall.
Can I say you not only did it first try, but you actually found a solution that I haven't included.
Ooh, okay.
So there we go.
So here was the guess that I had to take, was that if I tried to use set, it would have a built-in type. That was
yeah.
All right. So maybe let's walk through a couple other ways that we could do this, because I apparently found something that you didn't do. So should we look at the solution, or do you want to talk through another one?
Let's look at the solution.
All right, here we go.
Because the solution's interesting too. What's different between this and your solution?
So you dropped it in here. So we're telling the set itself to accept the generic.
Yes.
And what I did up here was say that the set that will be returned will accept the generic.
Yeah. TypeScript can do it either way. It can either infer from the return type, or it can infer the return type from what your actual code does.
Got it. Okay. And so this is like, both of these look pretty clean to me. I think this, yeah, I feel like I would have gotten here eventually. But here's the other thing. If this wasn't like a built-in type, like if VS Code didn't just know what a set was,
yeah,
this would be way easier than trying to figure out how to get the type for a set.
Yeah, totally. Like this way, it's really, so there's a couple of wrinkles with this whole setup, which is that if you notice that T-type here inside, where are we? Yeah. Here, we're not actually using it in any of the arguments of the function. So it's not actually being inferred anywhere. If we were to pass like a T-type here, then we could actually remove this and say like a as string, or like hello. And now it would infer string from the argument that's being passed in. So because we're not passing in an argument, we're actually using this generic slot as a kind of a slot where you can pass in a type yourself.
Right. And so what we're saying is you have to decide here. Like you are not, if you don't use it, it will be unknown.
Exactly. So this is very similar to if you've ever used React, then you would say, you would have a use state here, and you would have like a ID set ID, and you would have to manually pass in here that it's a string. So generics are interesting. They can be inferred from TypeScript itself and from just like the call, but you can also override them at the call site and manually pass in your own stuff.
Gotcha.
Trash. Matt and Jason dunk on trash. Yes.
I was dunking on the entire chat trash, not you specifically, but I mean, yeah.
I got you, man. You're gonna raid us. You're like, you gotta be prepared for this stuff, you know.
If you hover over set in the code, it will show you the generics available.
Yeah, that's true. If you command, and here's something crazy you can do. Try command clicking on set.
Command clicking on set. Ooh, here we go. Here we go.
Double click inside here to open it up. Yeah, just there. Perfect. So now we are in lib.es2015.collection.d.ts. We're in a spot where my VS Code live share cannot follow you, by the way. You are in the deepest, darkest dungeon of TypeScript right here. These are the type definitions for the JavaScript language itself. We're down with the Balrogs and down with the scary beasties. And we can see here all of the methods that are implemented on set. So we've got set add, set clear, set delete, set for each. And here's something crazy. We can actually we can comment these out. So if you comment out lines 59 to 64 or whatever. Yeah, go on, let's break it. Let's break JavaScript.
No.
And now try and go back to the problem.ts file, the one just in the tab over there. And now try and do anything on these string sets or number sets. You say string set dot has foo. It's going to yell at you because has doesn't exist on the set anymore.
No, I hate it. Okay. Yeah, and there. Okay, so then it comes back. So if you ever want to, if you do end up being one of those folks who works in an office, I guess the 70% of us who are not me, I don't work in an office, but if you are back in an office and you want to ruin your coworker's day, Matt Pocock has provided the solution. When they retaliate by trying to ship their enemies glitter, give them Matt's address.
Come on. I freaking hate getting glitter in the mail, actually. It's really rough. Like sequins and stuff in the post, I sometimes... it's genuinely the worst. We've got little cats as well. I don't
think there was a service, I don't know if it's still live, but there was a service for a brief moment called Ship Your Enemies Glitter. And they would just send an envelope completely full of glitter so that when you open and I think they did something where when you opened it, it would kind of like make the glitter come out of the package. Yeah, it's a little rough.
Awful. But yeah, well done on number 3. You smashed it.
Smashed it. Okay. All right. Now I want to, are we doing, should we just keep going on 4 or 5? Where do we want to go?
Let me have a look.
We've got time checking. We've got about 35 minutes left. So if there's anything you really want to show, let's make sure we get there.
This is lame, but I think number 4 is actually a really good spot to go to next.
Okay. Fetchers is an object where you can optionally pass keys that match the route names. So these would be our route names. We want this to error. How do we prevent the user from passing fetchers that don't exist in the routes array? Ooh, okay. So I've seen a thing in TypeScript that I only lightly understand where people do things like pass in key of or value of. Is that the direction you're trying to go right now?
I'll give you a clue here, which is that the thing that the question is asking you for is impossible. And so
interesting. Okay.
What it's asking you to do is try to find an API that would handle this. Because if we think of a generic has to exist in the context of a function, right? It has to be something that you pass in or is inferred and then returns something else. And there's like, I'm expecting you not to be able to solve this one, by the way. So we can like shift over to the solution. This is like an extremely tricky one.
Wait,
This is
wait.
interesting.
No, we can do it. We can do it. So
Okay.
if we pass in, like if we
I'm just
make
going to shut
fetchers
the window,
into
by the
a,
way. So I'm just going to just
literally leaving me to my own devices. Good. All right,
when I come
chat,
back,
we're about to
you've done it,
learn
yeah?
TypeScript with Jason. I'm going to make it all up on the spot. It's going to go great. So what I want to do is I want to pass in, okay, so if I want to pass in the routes, right, and the routes are going to be one of these, pronounced
No, this will
trout.
work. This will work.
Yes.
But then I would pass in, no, one of these. One of these. No, I'm already lost. Okay, so let me pseudocode what I'm thinking, because that'll be easier for me than trying to write TypeScript since I don't know a lot of the syntax. So what I'm picturing here is that we're going to return these objects. And so like each of these would be like routes.map, then you get your route, and then that's going to return back the return, right? So we get our actual route, or no, it would need to be like an object, which would be route, and then that passes in this function. I've done something terrible here. Oh, I've double wrapped it. Okay, so this is this would sort of give us the ability to do this, and then if I knew that this was going to be a route, and then each of these needed to be, oh, wait, huh? No, not quite.
So this is what you're building here is really cool because it shows the constraint of the problem. If you think about troot here, this declaration, this generic, is only valid for this scope. It's going to be
won't
out
come
of scope.
down.
Right. Exactly. It won't, like, you can't pull it in from outside the function. So we somehow need like troot to be up here in the top level.
Gotcha. Okay.
This isn't valid syntax, right? So how are we going to get around that?
So now we need to start like identifying a type up here, or I guess whatever interface, and then this would be config, and that would take a troot.
Yeah, there's definitely something there. You're on the right track, getting warmer.
Okay, and then I would get my routes, which is going to be the array of routes, if I can write
correct
accurate syntax.
Yeah.
Okay, and then it would be like fetchers would need to be one of these.
You don't need to redeclare the troot again because it's already in scope.
Oh, all right. So then I'm going to get my routes, which would be troot like this. And then that's going to return. Wait. And each of these would return back the... all right, my syntax is failing me. How would I declare that this is... like that?
Yeah, this is tricky because what
no,
we
but
want
that's
to
still wrong
express
because
here
that would have let anything come in. Is there a way to get like what was sent here to pass in here? Can you do like a value of, or like a, because what I would do if I was actually trying to check is like if root or it would be like roots, we'd have to rewrite some code here, but right, you'd do something like that to say like if what you're being passed is included in this route up here, then you can go, otherwise you would need to throw an error. So I want to do the same thing by getting whatever the value of roots is and then passing that in here, which is exactly what you've asked me to do, and I am now unable to do it.
Well, like, this is hard because what we're doing here is we're saying this slightly changes the API down here,
Right.
Because down below, sorry, in fetches, we're no longer saying this is like an object. We're saying it's a function.
And I'm not allowed to refactor the code.
Well, you are a bit, but the issue is that our function here is in the wrong place. Get fetches is no longer needed as a basically. I tell you what. I think if we go to the solution, it's going to elucidate kind of what I'm saying better than how I can say it. Because you are super close.
K in T route. Oh, I knew it was possible. Dang it. So yes, all right. So this is the value. Is that right? So
this is kind of like if
X
we
in
go,
Y is so when you do like an X in Y, right? It would be like that would do the 1, 2, 3. This is the X and this is the Y. Okay.
Yeah, exactly. Sorry if you can hear a storm blowing outside. It's absolutely crazy here. So yeah, what this is doing is it's basically creating an object out of the roots. So if I were to create a type fruit, for instance, is going to be K in apple or banana, and we create a string here. So we say const fruit is fruit, and then inside here, it's going to ask me for apple and then banana. And I can add things to this. So I can add things to this union. I can say cheese. I know it isn't a fruit, but I'm going to put it there because that's the only thing I can think of. And this is basically creating an object from these types here. And troot is going to be a union of the things that we pass in.
Right. Okay, so more practically, what that means is when we pass this in, right, we get these values. So what this is becoming is this.
Exactly.
And so that also works because of the way that we've defined this code. But it's not flexible because, again, you've hard-coded everything.
Exactly. So that then, if we revert that, that troot represents the union of those three things there. And we can see, though, that it's not quite perfect because if you look down at config objects here, and actually if I add in in fact, this is going to blow your mind, first of all. If you go into fetches there and try adding a new one to that object, first of all, you can see like all the autocomplete in there, but try adding a new one.
Autocomplete is already amazing.
Yeah. And you'll see all of the stuff we've added in there, it's all in there.
Beautiful. Absolutely beautiful.
So cool. But it's actually not working as well as we think it is, because if I add something else to this, if I go like not a root, then it's actually going to yell at me because it's saying, if you hover over that error, not a root is not assignable to thingy. Because we're actually passing in the generics up here.
Oh. Wait, and we can't just leave that out?
No, if we leave it out, everything falls apart.
But what if we do that?
Then we don't get autocomplete down here.
Boo.
Boo. Yeah, quite.
Okay.
So the lesson here is that generics cannot exist at the scope of objects. They have to exist within a function. So let's have a look at solution 2, because I think you're going to like that one a bit better.
Okay, so we've got config object, trout, extend string. Okay. And now this, by extending string, we're saying that the route has to be a string. That's what we mean when we say extends.
We're constraining it to be a string.
Got it. So we set up our routes as an array. Same thing here, K in route, and then we're allowing any on the way back. Cool, that's all fine because that's not really what we're worried about here. Make config object. So we're passing in the T route, extend string, and then we need to get back a config object that gets past a T route, right?
We're not
So
getting
now,
that back. We're actually passing that in there.
right. Oh, okay, I see it. So I see. We're like doubling up here. We've got a generic here, but we have to get that generic into here. So we're kind of doing double duty. Do we need the double extends, or would this one kind of pass through?
Let's try deleting this one and see what happens.
Okay. Now it's unhappy.
And then what error? And it's also unhappy on line 13, which is the more crucial error.
Troot does not satisfy the constraint. Okay, so undo that. Now if I do this, unhappy, not assignable to type string or number or symbol, because this didn't...
That's because only strings or numbers or symbols can be object keys, and we're creating an object out of troot there.
Okay, so it won't pick up this inference if you pass through.
Correct. Yep.
Okay, so we've got that there, and then we have this function to make a config object, which is more what we wanted, which is then picking up all of these. And if I delete this, now it says is not assignable to type. A little messy, but it does now give us our autocomplete, and we didn't have to hard code those anywhere.
Exactly. And if you add a new root, it's going to give you more things to autocomplete.
We can get rid of the error, which is cool.
Exactly.
And then in here, do one of these, and there it is. Okay, so this feels extensible in a way that doesn't... The thing that always makes me nervous about TypeScript is I don't know how to do this, right? So the way that I would have solved this problem is by literally hard coding all of those routes in. And then you have that problem where you've got two versions of your hard coded routes, and then it's just like, it just sucks, right? So my way of solving it would be like, just write the code to do that check in here, make that a function, like what I started doing originally. But this feels nice because it does what we expect.
Exactly. And it actually lets you pull more logic out of your runtime code into your type level code. So now we're actually shipping less logic to the browser or to the whatever, because it's more constrained within our type code. And now that make config object, that could live in a library, like that could be something you distribute across your organization. And suddenly you've got like this type safe router fetcher thingy that is now available to anyone who wants to use it. And you notice that when we actually use it down in like line 16 onwards, there's no type definitions here. There's nothing you need to add to it to make it do its thing. It's just giving you the inference for free.
And I saw a question from a first-time chatter, Charles. The way that we're both typing on the screen is we're using VS Code Live Share. That's a plugin that you can get here. Where's the actual here? So this is a pretty cool service. If you've never used it before, definitely give it a shot. Tons and tons of first-time chatters. Welcome everybody. If this is your first time seeing the show, I'm excited to see you. Hopefully you want to stick around. Remember, you can always subscribe to the channel, follow all those sorts of things so that you know when we're going live. We got 2 of these a week. It's a lot of fun. Okay, what should we do next? We got about 20 minutes.
Let's do one that's okay, let's go to number 8. This is a really famous error because it gives you a really hard to understand error message. And understanding why it gives you the error message is really crucial to understanding generics itself.
Okay, and that was which number? Sorry?
Number 8, sorry.
Number 8. Here we go. Okay, so let's take a look here. We've got object as const, Interesting. Object, key of, type of, a lot going on in there. So wait, key of, type of, object. So this is the object. Key of, type of would give us the union of ABC, right?
Exactly. If you hover over object key just
and
there,
that's exactly what it did. Okay, great. Then we want to get the object key. So T key extends object key. And then we want T key equals A. A is not assignable to type T key. A is assignable to the constraint of type T key, but T key could not be instantiated with a different subtype of constraint.
Yeah.
Okay. So that means this matches technically, but if somebody put in a B, it would break because it would match this, but this one is being stripped down to just A. Is that correct?
No.
Sort
of. I'm going to let you flail a bit longer.
Okay. So let's think a little bit more here. Type of 1 by default should be here, but it's not doing it. Okay, so it's not picking up our default value. And it's not picking up our default value for reasons I don't understand. Because I actually have no idea. Why doesn't it pick this up?
This is really brutal. This is like a really hard one. If you hover over 1 by default there, this doesn't really give you a clue, but it tells you that if we don't pass in our get object key there, then it's giving us either 1 or 2 or 3. Because what's happening there is if you hover over this part of it, it will show you that when we pass in nothing to this function, the generic gets locked in as the widest it can possibly be. Because you see here that the generic is extends object key, like we're constraining it to be object key.
Right.
And if you don't pass the thing it's assignable to, or you're assigning it to, then it defaults to the widest it can possibly be.
Right. So because we don't actually pass this argument, this assignment doesn't happen. Is that right?
And it doesn't happen and because it happens at the runtime level, but it doesn't happen at the type level. And so what's happening is that error is saying, if you hover over it again, A is assignable to the constraint of type T key, but T key could be instantiated with either A or B or C. And the different subtype of constraint is basically saying it could be either B or C, and this default doesn't account for that. So that's really hard to deal with, and there is a trick to do it, basically, and it will get you out of a lot of tight spots. And this always happens whenever you try to assign a default parameter that is more narrow than the generic slot that it's supposed to inhabit. And I can tell by the tone of your voice that you want me to show you the solution instead of like.
I'm going to be honest. I don't even know where to start. Because I know what you're saying. We need the generic here to somehow be more narrow, but I don't even know where I would begin.
Absolutely. So the way to think about this best is if you actually go to I think number 2 and then solution 1. Remember, we returned to this idea of function overloads, which is if you call a function in one way, it's going to return one thing. If you call a function in another way, it's going to return another thing. Well, one amazing thing about function overloads is you can actually provide different generic parameters based on each overload. So you can say, if I just sort of scaffold some syntax for you here, we can say, let's imagine that we say a or function that gets something. we can say that if you pass in A is going to be 1, then you return 1. And I'm just going to like have the implementation down here, which is going to be any, and then return as any, just to sort of shut up TypeScript.
Okay.
So if we call get something, say const result equals get something, and then we say if we pass in R1, then if you hover over this result here, that's going to be typed as 1.
Okay.
Oh, sorry, if I move myself out of the way. If we add another overload here, then we can add it and say, let's say you pass in, I don't know, A, which is going to be Matt, B, which is going to be Pocock. And we're actually going to return here Matt Pocock.
Okay. So then
this too. Matt and Pocock. And then that result is going to be Matt Pocock. But now what if we wanted one of these signatures to be generic? We could do like, let's imagine that I want to add someone new to my family, and I say tname, and now we're going to put in tname here. TypeScript actually lets you do string interpolation too, so you can do tname Pocock, although I do need to make sure it extends string.
Okay. And so
I think the reason that we sort of looked at earlier.
We throw in another name, like a... And now it's smart enough to know.
And we can end up with Robert Pocock. Exactly. Okay. Whereas if we just add 1 back in here and now hover over it, then it actually doesn't even try to fill the generic.
And if we just throw in just the 1, it's like, nah, get out of here.
Exactly. It's actually going to like try to resolve the first generic because that's the only one that even remotely fits. But it's also going to error here by saying that, you know, if we try to say Nancy Smith or something, then that's going to error too. It should.
Or it just overloads as...
That's really weird that it's... I think we found a bug in TypeScript there. Actually. That's not normal. That's no good. Well, okay, let's go over that quickly. But the basic idea here is then we need an overload that... Because there's 2 different cases here. There's the case where we actually pass something, and there's the case where we don't pass something. And on the type level, those are 2 very, very different things. So I'll do some refactoring too, just so.
Right. So in this case,
function declarations.
We need key A, and that's going to return A. And then the other one is the generic, but it doesn't like that. Why doesn't it like that?
It doesn't like that. We've kept the default parameter there.
Oh, so we can just drop the default parameter.
Exactly.
Or, wait. But don't we need that default parameter? Because otherwise...
There's actually a slight mistake here, which is we're trying to look at this one here. And actually, in this case, when we don't pass anything, we don't pass any arguments. So we shouldn't put an argument.
Oh, you're right.
Here.
You're right. Okay, so, whoops. Get rid of here. Okay, so that's happy. Now, that's A. But now everything else is mad because it wants these. So I have screwed up our overloading.
We still need to get rid of the default parameter too. So we don't need that anymore.
And now this is unhappy because not compatible with its implementation. And that's because...
That's because the way that function overloads work is that each one, if you imagine them stacked up, they have to be compatible with their eventual implementation. And the one at the bottom is where you actually implement the function. The other ones are kind of like reflections above it that say you can do this or this or this.
Okay.
But the way that we would make these compatible is we would say you don't have to pass T-key here. You can actually do this.
And we make it optional.
That works. Maybe that doesn't make it optional. In fact, you know what? I think what we need to do is sort of brute force this a bit and say, by the way, this return type here, we're not actually returning A because we're using the A key to access the 1 here.
You're right. So this would instead be a 1.
exactly.
right?
And what I'm going to do instead is I'm going to just move this one up to here
Okay.
and say this is going to be, if I just get this crud out of the way, and the key is T-key, T-key. Then we're going to say type of obj. We're actually going, we need to kind of like declare the return type here. We're going to call it type of obj T-key. Now, that
Okay.
syntax there, how scary does that look?
Looks pretty terrifying.
Yeah. What we're doing there is if we say, let's say we go type whatever equals type of obj, and we're going to pass in b here.
Mm-hmm.
What type is that whatever going to be?
It's going to be a number, right? Because
Is it
type
going to
of
be a number
object B
or
is going to be this. Oh, it's going to be two, the literal 2.
the literal 2? Exactly.
Got it. Okay.
Nice. How about if we pass in B or C here?
Then it's a union.
Correct.
Okay.
And in this case, then, we know that T-key extends the key of our object because we've got it there.
Right.
And that means that, what does this then mean?
This ends up being type of object T-key. So basically we're saying whatever gets passed here, we expect it to be the number literal that's inside. Okay.
Exactly. Yeah.
Now it's still unhappy because implicitly has an any. Can be used to read only. Okay. So the piece that I'm missing here is that I don't know how, like, because we need this code, right?
Yeah. We don't. Yeah, we do need this code. What we now need to do is, let's see, why is this erroring here? String. The reason is that key here is typed as, if you hover over that word there, it's typed as string. Why is it a string? How can we make it more narrow than a string?
One of these, right?
Yeah, except we don't, inside the function signature itself, we probably don't need to redeclare, like the way that function overloads work is you don't need to is they get sort of like wider as you go down, basically. Yep. And so this T key here, this one is only relevant for this declaration there.
Okay.
And so actually what we want to do is, instead of T key, we just want to put it to the constraint, which is object key.
Okay.
Which is up here.
And now it's happy.
Now it's happy. Because we've kind of like manually gone through and specified all of the different cases that we've got there. Because before, what we had was, like, on the type level, we were going, okay, I want you to think about A or B or C, but by default, I only want you to do A. And we were trying to do that in like a tiny syntactical space. And TypeScript basically didn't understand what we were doing.
Yeah, this is, yeah, it goes fast. But yeah, but there's like a whole chat going on the side here. I'm just checking to see if there are questions. I don't see questions. And chat, if you are able to, if you have questions, definitely let us know. Are you able to comment out line 14 and have it work? No, because we have to have this base case of no argument, because this one expects that there's an argument. So we are, to just explain this back and make sure I understand it, our function here needs to accept a value. A default value is A, and we need to make sure that that is within the constraints of the object key, which is our union of our available keys. And if we add another one down here, this will expand to include D, right? And then, so when we go with zero arguments, we know that we're going to default to A. So we need to return that, because that's what our function does, right? So our type becomes 1. So in this default case here, we know that we're getting 1. And then for all these other ones, our key, what we're sending, needs to be one of these values. And then we are returning whatever the object contains for that key. And that allows us to then send our default.
Exactly.
Okay, my brain hurts.
Let me show you just like, yeah, this is tasty stuff. Like this is like solving one of the biggest pain points in TypeScript generics, right? It's that instantiated as subtype thing. When I tweet out and say like, what's your least favorite error message to see? This is the one that people reply with. So this is trying to work around a horrible error message inside TypeScript. Mm-hmm. And we have a repeatable way to do it now, which is great. But yeah, this is, I think, a good place to end on, because this is the really hardcore stuff.
Yeah. So one more question here. Why couldn't we just delete the base case and make the key optional? So that's a good question. So if we take this, and let's see if we can do this in 1 minute because we're out of time. So get object key, and that would be T key extends object key, and that's going to take the key, which is optional now, and that takes a T key, and it's going to return type of object T key, and we want the default to be A, right?
I'll fix this syntax briefly.
Okay, so now it's sort of happy, but it gives us the exact same error.
This is where we started, basically.
Right. So it looks like we have to do this overloading because this inference is too hard. Like there's probably a way to make this smart, but like not basically this overload is what makes it all work, right?
Yeah. To answer American 250's question too, another thing you could try, and I have tried, is you can actually give,
sorry.
Come on. Is you can actually give this, like, you can give the generic here. Can you tell I was a voice coach, by the way? Drama degree coming through, real strong. You can give this a default case, right? You can give generics a default case, which is really interesting. This feels like it should work, but it doesn't, because it's still the same problem. You're still coming up against this could be A or B or D or C or D. It's kind of like you're trying to override this with this, and TypeScript won't let you.
Yeah. Okay. So this feels like one of those cases where like my instinct would be to refactor this instead of trying to type it. I'd be like, okay, let's just write this function to be simpler so that we don't have to do this. Exactly. And it sounds like we're out of time, so I'm going to start signing us off. But is this the sort of stuff that, like, are you covering the, like, sure you can, but maybe you shouldn't part of TypeScript?
Yes, absolutely. I mean, TypeScript imposes API constraints on you, and mostly those are good constraints because they force you to do more functionally. They force you to do more in terms of designing your API so that inference flows through your app. But sometimes they're bad constraints, and so there are exercises in my course where we look at something that is impossible, and ways to work around it. But also you should maybe be thinking about designing your API in a slightly different way to take advantage of TypeScript instead of fighting it.
Right. Okay, perfect. So with that being said, I just dropped links to Matt's Twitter, to Total TypeScript, which is, if you want to go further than this, go sign up here, and to the repo that's full of the challenges and solutions. So go and run through those. This show, like every show, has been live captioned. We've had Amanda from Whitecoat Captioning here. Thank you very much. And that is made possible through the support of our sponsors, Netlify, NX, and New Relic, all kicking in to make this show more accessible to more people, which I appreciate very much. While you're checking out things on the site, make sure you go and look at the schedule. We've got some really, really good stuff coming up. I just found out today we are going to reschedule this episode with Will, but I will be here on Thursday. We'll do something. We've got a couple weeks off. I'm going on to a company all hands and then vacation, and then we'll be back strong with a whole bunch of good stuff. There's more here that's not on the schedule, so make sure you follow on Twitch, subscribe on YouTube, add on Google Calendar, all the things so that you get notified of new episodes when they are scheduled, and then once they've gone live for the wherever you want to consume your media. Matt, any final words for everybody before we call this one done?
Thank you so much for having me on. You've been a wonderful chat, wonderful audience. It's been good viewer numbers. Everyone getting excited about TypeScript. Love it.
This was an absolute blast. Thank you all so much for hanging out. We're going to go find somebody to raid, chat. So stay tuned for, let's see, Ben is live right now. So we're going to go raid Ben D. Myers. Thanks all for hanging out. We'll see you next time.